Hey everyone, this is the SnapRx team, and we're here to do our final demo for the SnapRx app. So we're going to start by introducing the team.
Hi, my name is Lynn.
My name is Andrew.
My name is Zachary.
My name is Manish.
So first, I'm going to go over a quick introduction of SnapRx, just its features, and the general purpose of the app. So we have three primary features in SnapRx, which are user-provided text query, user-provided description, and user-uploaded image, and each of those are used for classifying a prescription medication. So in order to classify the medication using our image upload method, we use an image classification model or a computer vision model, which is trained on over 80,000 pill images from the NIH Pillbox dataset. And our model has an accuracy of over 44% on a group of classes, or a group of over 200 classes. The primary purpose of SnapRx is we want to give users quick access to prescription data on potentially non-identifiable pills, in addition to manufacturing data, ingredients, and pricing information whenever it's available.
The problem we are trying to solve is identifying prescription medicine that has been separated from its packaging or is otherwise unidentifiable, because medicine that cannot be identified would otherwise have to be discarded, and mistakenly taking unidentified medications poses a severe health and safety risk. Current solutions to this problem let users manually search medications but do not have image classifier. With our application, if a user spills their pill bottle in their toiletry bag, they are able to scan and upload an image to the application or enter the description of the pill.
Some other use case for SnapRx is an individual prescribed medication that notice in packages pills that would like to know what medicine is it. They can use the scan image option of SnapRx, and let's say a doctor or a similar medical professional who knows the name of the bills but would like to know more about the detail of the bills, they can use search by name features of the app. And let's say a pharmacist who know the features of the bills, such as the color, the shelf, or the imprint, and they would like to know more about the information of the bills, they can use the search by attributes of the app.
So our goals with SnapRx, our primary goal was to use computer vision and machine learning to identify unpackaged medication images and implement that in our application. We also aim to provide detailed medication information on all of the 80,000 plus medications in our database through a user-friendly interface. We're also set out to provide an efficient and accurate tool for anybody to identify prescription medication and gather pertinent medical details, and also save those medications for which they searched up and analyzed, and also provide a versatile set of methods for pill identification. So not only scanning the pill with a camera and doing image recognition, but also through text search and description search.
So really quickly, we're just going to go over the different technologies used in SnapRx. So for the backend, we primarily used Flask and MySQL. Flask was used to develop the server code, and Flask RESTful was used to develop the REST API endpoints for the server. MySQL was used for the database, and both of those were hosted on AWS. As mentioned before, the NIH pillbox data set was our primary data set used for gathering medication images for different prescriptions. And it was that same data set we used to train our Curis model, which is the image classification model that's being used. One thing worth noting is we originally used PyTorch to train the model, but since it wasn't gaining the accuracy that we desired, we decided to switch to Curis to have a better performing model.
We used React Native along with JavaScript to develop the user interfaces of the front end, and we utilized Expose CLI to run the application on Android and iOS.
All right, so now we're going to demo the app, and this is a test scenario where I'm going to play a user who has found a medication loose in their toiletry bag, and they want to identify it. So I've just opened the app here, and we're going to go to Scan Med as guest because we're trying to identify it quickly, and then select image from camera roll. And we're just going to pick the image corresponding to whatever we found in our toiletry bag. And the program is going to give us a predictive medication class and also the model's confidence in that prediction. It's also going to show us an image corresponding to that class so that we can determine whether it's an accurate prediction or not. And then we also get a list of possible matches for medications that are contained inside that medication class. So we can click on any of these matches and we'll get a medication details page, which is just going to provide some basic information about the medication, including the imprints, the color, and the shape, so that we can determine whether the model's prediction was accurate or not. So if we back out of that, we can actually go to sign up instead. So if the user preferred to sign up for an account so they'd get access to the full features of the app, we'll just enter some test information here. And this will essentially allow the user to do the same thing we've just done, which is identify by an image. And they can also perform additional actions in the app, so they can save medications to their account, or they can use any of the other features, which we'll be going over shortly. So we're going to go ahead and sign out really quick because this account doesn't have anything on it. And we're going to sign into an account that does have some information for us to demo. And then Lynn can go ahead and take it from here.
So this is the SAP medication page with all the medication that you already saved. If you click on one of the medication, and you can see the medication info and an option to remove the medication.
Yeah, so now moving to the search medications page. So here a user can just enter in any medication name that they're thinking of, and it will autocomplete with suggested results that closely match the inputted text. And then when a user selects a result, they're taken to the same MedInfo page that we saw earlier, that same kind of format where you have the medication name, details, color, imprints, and ingredients, and all the other information. And then on the same page, you can also add it to the MyMeds page that we were just previously at, which will allow it to be seen on that page.
All right, so going back to the scan medication page, this is the same page that we used as a guest. It's also accessible as a user. So basically everything here is the exact same. There's nothing more to explain here. It'll provide the predictive medication class, the confidence, and also the possible matches.
On this on this UI, we can search the medication by description. So if you choose a round and white pill with, let's say, the imprint 60 on the front, we get 3 medications. And here we have the same medication info as the other screens. And we can also add this medication to our My Meds.
Those are all the main features of the app. So we're just going to quickly demonstrate on the profile page that user details can be updated and also the password can be changed. These aren't features that are critical to the functioning of the app. It's just quality of life for the user.
Yeah, and finally, should the user want to delete an account, they can.
All right, so that's the entire app. We're not going to go through and delete an account right now just because it'll take a bit of extra time. But thank you for watching, and that's our full demo.